a buck converter changing 240 volts AC down to 5 volts DC. Beautiful little thing. I got 5 of them. I wanted some more. The beauty is that the input comes in here, the mains comes in 250 volts this side, 5 volts out that side, and that then can feed a battery charger, lithium cell battery charger. I can put 6 of these together and charge 6 cells in series because they will be completely isolated from each other. The problem is that one of them's gone bust and doesn't work. I've tried to find out why, and I can't get anywhere with it. I can't understand why it doesn't work. If we look at the circuit diagram, what I've done is to reverse engineer it. Quite a simple, straightforward thing as far as I'm concerned. Has a diode bridge on the live and neutral. That then produces a DC current of a voltage of something like 340 volts across this capacitor here, which is rated at 400 volts and 4.7 microfarads. This then is nasty because it has the 340 volts on even after it's been disconnected from the mains, and therefore can give a nasty belt. The thing itself, come on then, is based around this THX208 chip, which just drives the transformer coil here, and it also has another transformer coil here, which is how the THX280 gets its supply. But unless it's oscillating, then it can't get a supply, and it can't oscillate until it gets a supply. So it has this other connection over here, a couple of 1M resistors onto pin OB. OB then should get enough current to be able to turn it on, to start it oscillating, to give it its feedback onto its voltage pin. It then drives this depending upon the feedback. So here we have a light dependent transistor, which is driven from the output side, which is this diode here, which then drives the input side here to tell it what the voltage is. This then, the current comes through this diode, which rectifies it, giving us this capacitor here to smooth it, and this then comes into this setup here. It has an LED on it, and this has called a shunt regulator, a 431 shunt regulator. I've tested this, and this seems to work okay, so that if we put, where are we, come on, there we are, if we put the potential divider, obviously changes as this voltage changes, then this voltage here is going to change. Quite a peculiar situation, but it seems to work because the voltage from coming in just goes up slightly, but once we get to 5 volts or just over 5 volts, the voltage out goes down from 3.4 down to 1.4 volts on this LED, which will signal that opto transistor and should send information into FB. But it won't boot up. Originally I couldn't get a voltage across this capacitor, so I took out the diode bridge and resoldered it, and then I got a voltage across here. But then I couldn't get any further. I got a very large voltage here at OB, but nothing else on the circuit. So essentially I'm snookered. I assume that it must be this chip that's gone, so I've given up working on it. What is that chip then? Well, that chip is, can we see it? Unfortunately I can only get the data sheet in Chinese, which is a bit unfortunate. But essentially we've got a couple of transistors here. We've got OB coming in here. The initial voltage comes in. Presumably it goes to this block here and to this transistor here. This transistor then, when this is high, switches on this transistor, which then sends a signal into here, which then sends a signal to the start up here, which enables an oscillator. So over here we've got an oscillator. It has a capacitor on the outside. That gives us our sawtooth waveform. Well, at least it charges up. And then I assume that this transistor here discharges it. So we have the CT charging up till it gets to this point here, when I assume the transistor switches on, discharges the capacitor, producing this output from this device here, which has two oscillators on the output. One of the oscillators here seems just to come along. It goes to this device, which looks like it's a set reset device, and also to this transistor. So when this transistor is switched on by this oscillator, then it shorts out this particular waveform here. So this waveform has a pulse on it generated, and then this oscillator, using that transistor, switches the pulse out. This then is IS, which comes from this part here after this second transistor, and that then feeds back into this device, and also comes out of that device. Not too sure which way it's going, but this signal here then has this pulse removed. That then goes into this comparator, which has got the input, the inverting input set to 0.8 volts, so therefore 0.6 volts, so anything that is above 0.6 volts then is going to give us a pulse out of this comparator into here. This then device can control these two, or one of these two transistors, and these transistors then, one of them, they short out the input from our opto isolator. So this can happen for two reasons. One here is going to short it out, and the other one comes from over here where what? Oh, we have a comparator here which is set the inverting to 9.8 volts, and therefore if the non-inverting gets above 9.8 volts, then it's going to output here and is going to switch on this transistor, once again switching off this input. So yeah, a very interesting sort of gizmo. I don't really know where I'm going with it from here. It's really like it, but can't get very far with it unless I can replace that chip. I think that must be the fault. Must be the chip here. This must be the fault. I can't find anything else. Everything else looks to be okay. As I say, I've tested the output, connected it the wrong way round. It's perfectly okay to do that, I think, because what we have is a diode here. So even if I feed 5 volts or a voltage in here, it won't get to the coil. It'll charge the capacitor and it will operate this particular shunt regulator, which does seem to be working. I'm getting the rectified mains onto here, so therefore there doesn't seem to be much else that can be faulty. I've checked the diodes D5 and D6. Wherever D6 is, I've lost it now. I can't see D6, but anyway, I've checked those diodes and they all seem to be okay. Check the bridge rectifier, that seems to be okay. So the only conclusion, I've checked most of the capacitors and resistors, this capacitor, the only thing left is this chip here. I haven't got another one, so it's not much use. So it's bye now, bye.